this load W which is applied, that load is not acting at the directly perpendicular to this axis. So what we can see, that the loads which are applied on each bolt, that load will be different, intensity of that load will be different, and that intensity of bolt or intensity of that load, that we have to calculate. Okay, so let us again consider, as we have considered last time, that this is the line about which we are going to take movement. So I will draw this line. We are going to measure about this line all the distances as well as okay, the line which has drawn at AA, this line about which we are going to take all the movements. Okay, because this is what the tilting line which we are going to call as, about which this total plate or this socket will get tilt. Okay, which may be perpendicular. Now this is actually AA line is perpendicular at in this diagram, whereas here it is this AA line. And from this section AA or line AA, we are going to take the L1 as a distance of this bolt number 1 and 2, and L2 is the distance of bolt number 3 and 4. Okay, and this W is acting at certain distance L, that we will consider as a L distance. Okay, now in this case also we are going to calculate the intensity of that load per unit length, this WS. But while we are going to consider this WS, CS suffix is used. In previous case it was used as a WT. So what it means, that it was a tensile stress and now here it is a shear stress. But if you are going to look this diagram, then what you can see, that this W is directly going to create shear in this bolt number 1, 2 and 3, 4 also. So this W will create either one movement which will be creating tension in this bolt as well as here also, whereas it is going to create direct shear. So this case will become case of direct shear and tensile load. So first of all, we are going to calculate the shear which may be sustained by means of this 4 bolt. Okay, so the shear which is occurring in each bolt, or the load which is supported, this total load is W, and load which is supported by each bolt, that shear load that we can say, that shear load will be that WS, the direct shear load, will be W divided by N, because W is the total shear load which is sustained by means of this 4 bolts, and hence we can say the each bolt is going to contribute equal to W by N, where the N is the number of bolts which are used. Got it? Now when we are going to, we have calculated this direct shear force, then what we have to do is that we have to calculate the tensile load which will be created because of the eccentricity. And here this W will try to tilt the bracket, okay, in clockwise direction. As in this diagram, W will try to tilt this bracket in clockwise direction. This direction will be like this. Okay, this bracket will be get tilted because of the load W which is active, and it will create tension in this bolt, that is bolt number 4, 3 and 4, as well as it will create tension in the bolt number 1 and 2. And that is depend upon how much distance these bolts are away from this section A, right? So that we will call it as a tensile load, okay? And this tensile load which is created in bolt 1 and 2, that we will calculate, okay? So first of all, we'll calculate the maximum tensile load on bolt number 3 or 4, okay? So as you know that this 3 and 4, they will be at same distance, that's why they will undergo to the same type of tensile load. So or same intensity of that tensile load, and that will be maximum. So we'll calculate that load first, and that will take for the design. So how we can calculate it? By means of calculating the intensity, and later on if we are going to add, that is the previous process which we have seen in the previous case, the intensity multiplied by distance, okay, and this tensile load multiplied by the distance of that load, respective load. Are you remembering it? Here we have calculated it. First of all, we have calculated the intensity, right? Very small w. In this small w is nothing but the load intensity per unit length or per unit distance from the tilting edge. First it will become hello. So intensity is calculated. This intensity here W2 it has called. Just we are going to call it as a W, because here in this case we have considered that tensile load is acting, but here is total tensile load, that is nothing but the load which is coming in bolt number 3 and 4, and that we are going to take for the design, okay? So that will be calculated as WL. L is nothing but the distance of W which is acting from the tilting edge, multiplied by L2. L2 is nothing but the distance of bolt number 3 and 4, that is farthest bolts from the tilting line, divided by 2, because 4 bolts are used, that's why it is 2. If only 2 bolts are used, then we should not have to take this 2, divided by 2 L1 square, where L1 is the distance of bolt number 1 and 2 from the tilting edge, plus L2 square, where L2 is the distance of bolt 3 and 4 from the tilting edge. If you have got it, it's okay. Should I repeat it? हॅलो, हे रिपीट करायला पाहिजे का? रिपीट करायला पाहिजे असेल तर आय विल रिपीट इट वन्स अगेन फॉर यू. त्या केसमध्ये काय झालंय की हा जो डब्ल्यू आहे, हा डब्ल्यू 1 2 3 4 या सगळ्या बोल्ट मध्ये काय करेल, पहिल्यांदा पूर्ण शिअर तयार करेल, ओके? त्याला आपण शिअर स्ट्रेस म्हणू. त्याच्या अगोदर आपण काय करतोय की शिअर लोड करतोय. आता जर डब्ल्यू हा टोटल शिअर लोड आहे, तर एका बोल्टवर किती येईल? 4 बोल्ट आहे, म्हणजे डब्ल्यू डिवाइड बाय 4, that will be the shear load which is sustained by each bolt. एक केस झाली, that is shear load and that will create the shear stress. दुसरी केस आहे की ज्यावेळेला हा W इसेंट्रिक डिस्टन्स L वर ऍक्ट होतोय, त्यावेळेला तो tilting तयार करत. That is nothing but it will create the movement. Okay, that movement we are going to take about the tilting edge AA. आता ह्या tilting edge ला एक vertical line जिथून आपण L मेजर केलाय इथून त्याच्या भोवती ती मुवमेंट असणार आहे, राईट. आता आपण काय करणार आहे की हा जो जंक्शन आहे त्या जंक्शन भोवती आपण पहिल्यांदा टेन्साईल लोड बोल्ट नंबर 1 आणि 2 मध्ये आलेला आणि टेन्साईल लोड बोल्ट नंबर 3 आणि 4 मध्ये आलेले. ओके, ह्या मुवमेंट कॅल्क्युलेट करणार आहे. त्यासाठी जसं आपण इथं कन्सिडर केलं होतं मागच्या इसेंट्रिक लोड काढताना, विल से W, हा जो W आहे that W as a intensity of load per unit distance from tilting edge, एक कॉन्स्टंट कन्सिडर केला आपण. ओके, आता W1 that is the tensile load which is in bolt number 1 and 2. Okay, so how we can calculate this W1? W1 is nothing but the intensity multiplied by distance. Okay, हा झाला tensile load which is coming in bolt number 1 and 2. ओके, आता ह्या टेन्साईल लोडची जर मुवमेंट आपण टिल्टिंग एज भोवती घेतली तर टोटल लोड मल्टिप्लाइड बाय टोटल लोड किंवा टोटल फोर्स मल्टिप्लाइड बाय डिस्टन्स, दॅट विल बी मुवमेंट अबाउट द टिल्टिंग एज. कारण बोल्ट नंबर 1 आणि 2 चं डिस्टन्स टिल्टिंग एज पासून L1 आहे, तर डिस्टन्स मल्टिप्लाइड बाय फोर्स दॅट विल बी मुवमेंट. आता ही मुवमेंट आपण काढली एका बोल्टची. ओके, त्याला जर मल्टिप्लाय केलं 2 न तर दॅट विल बी द मुवमेंट ऑफ बोल्ट नंबर 1 and 2, that will see later on. Similarly, we can say bolt number 3 and 4, the load which is acting on bolt number 3 and 4 due to the eccentricity, that will be W, that is the intensity of load per unit length per unit distance from the tilting edge multiplied by distance, that will be the force. And when we are going to take movement about that tilting edge, movement is nothing but force multiplied by distance. So this is the force multiplied by L2 is the distance. So that will be the movement of the force which is acting on bolt number 3 or 4. Okay, and if that we have calculated for single bolt, if you are going to multiply it by 2, that will become 3 and 4. Okay, so we have calculated these movements. या movement एकदा calculate करून घेतले आपण की आपण total load, total movement which is acting about the tilting edge काय होईल 2 into movement of 1 bolt. 2 why? Because 1 and 2 they are having same movement. That's why we have calculated for single bolt we have to multiply by 2 plus 2 into W L2 square, because W into L2 square is the movement of one single bolt. There are 2 bolts, that's why 2 is coming here. Okay, now this movement should be equal to the movement which is created because of this W. जर टेन्साईल लोड क्रिएट झालेली जी मुवमेंट आहे ऍट बोल्ट 1 2 3 4 ती जर ह्या W इंटू एल शी इक्वेट असेल तरच हा ब्रॅकेट आहे त्या ठिकाणी राहील. ओके, जर L इंटू W जास्त झाली तर ब्रॅकेट खाली येईल. जर L1 आणि L2 डिस्टन्स वर जे मुवमेंट आपण ऍक्ट केलेले त्या जर जास्त झाल्या तर ब्रॅकेट वरती जाईल. ओके, बिकॉज दे आर ऍक्टिंग इन अपोजिट डायरेक्शन विथ इच अदर. ओके, मग ती आपण इक्वेट करू आणि ती जर इक्वेट केली दॅट इज W इंटू एल इज इक्वल टू द टोटल मुवमेंट विच इज क्रिएटेड, that will be 2 into W small w L1 square plus 2 into small w L2 square, and hence we can calculate the intensity W जी मागाशी आपण कन्सिडर केली होती पर युनिट लेंथ आहे. ही इंटेन्सिटी जर आपल्याला मिळाली तर मग ह्यातले जास्तीत जास्त लोड कुठे येतोय, कुठल्या बोल्टवर येईल? ऑब्विसली 3 आणि 4 मध्ये येणार कारण ते लांब आहेत. त्यांची मुवमेंट जास्त असणार आहे. ओके, किंमत त्या मुवमेंटची जास्त असणार आहे. दॅट्स वाय विल टेक धिस मुवमेंट फॉर द डिझाईन. कारण ह्याच्यामध्ये जर घेतली तर ही स्मॉल असणार आहे आणि त्यानुसार जर आपण डिझाईन केलं आणि बोल्टचं डायमेन्शन काढलं तर ऑब्व्हियसली इथले बोल्ट तुटणार आहे बिकॉज ऑफ द टेन्साईल लोड. त्यामुळे आपण घेतानाच सगळ्यात जास्त मुवमेंट जिथे येणार आहे तिथली घेणार आहे. ओके, नाउ व्हेन वी आर गोइंग टू टेक इट फॉर द डिझाईन, but the tensile load on each bolt at a distance L2, that we will calculate as W2. तो किती असणार आहे? W into L2. आता ह्या स्मॉल w ची किंमत जी इथं आपण काढली होती, we'll put that value. So small w is nothing but capital W into L divided by 2 L1 square plus L2 square, and L2 is there. So that value we are calculating. Any question? हे समजलंय का? तुम्हाला समजलं असलं तर यू आर फ्री टू आस्क. हॅलो, हॅलो, have you got it or not? Just let me know.
Yes, sir.
Okay. If anybody is having doubt, any doubt, you are free to ask. You can write in comment box also. If you have any doubt, you are free to ask. You can write your doubt in comment box. Hmm? If not, we'll go further. Okay. Once you calculated this, then what we have to do is that one force which is acting on each bolt is shear force. Second force which is acting on each bolt is the tensile. So this case will become tensile and shear force combined. So we have to calculate equivalent tensile load for which we can design the bolt, or we can calculate equivalent shear load. Okay, so first of all we will calculate the equivalent tensile load, and then afterwards we will calculate the equivalent shear load. So we know that equivalent tensile load is given by half of the tensile load plus under root tensile load square plus 4 of shear load square. This will be the equivalent tensile load, and by means of this you can use the equation by means of which we can calculate the tensile stresses. So tensile stresses is equal to force divided by area. So that force which you are going to take, that force will be this W suffix TE, that is the equivalent tensile force. Okay, and when you are going to calculate the equivalent shear load, that equivalent shear load is given by half of the under root tensile load square plus 4 of tensile shear load square. As we have calculated, equivalent tensile stress is equal to half of the tensile stress plus under root tensile stress square plus 4 of shear stress square, and equivalent shear stress is equal to half of the tensile stress square plus 4 of the shear stress square. हे फक्त आपण स्ट्रेसचं पण काढू शकतो किंवा फोर्स. स्ट्रेस इज नथिंग बट द फोर्स डिवाइड बाय एरिया, आणि एरिया विच इज अंडरगोइंग इज सेम. त्यामुळे एरिया आपण रिप्लेस केला फोर्स न ह्या इक्वेशन मध्ये. ओके, वी कॅन डायरेक्टली गेट द फोर्स इक्वेशन. हे इक्वेशन आहे ज्या इक्वेशन नुसार आपण इक्विव्हॅलंट टेन्साईल स्ट्रेस किंवा इक्विव्हॅलंट शिअर स्ट्रेस कॅल्क्युलेट करू शकतो. तसंच आपण इक्विव्हॅलंट टेन्साईल लोड अँड इक्विव्हॅलंट शिअर लोड कॅल्क्युलेट करू शकतो. Okay, so we have to take both and we have to find the dimension. आपण दोन्ही पण जर कन्सिडर केले तर we have to find out the dimension. In this case, what we have to do is that I'll write the equation here by means of which we can calculate the dimension. What we have to write here? Stress is equal to force divided by cross sectional area. So cross sectional area when we are going to calculate, then what here we have to write, this is equal to now stress. While we are going to consider stress, it will be tensile or shear. Tensile stress is equal to force divided by cross sectional area. Then what we have to do? We have to take force. Force is nothing but here we have to take W. As we are going to calculate the tensile stress, that's why TE, that is equivalent tensile force, divided by cross sectional area will be pi by 4 d c square. Pi divided by 4 into bracket dc square, small d suffix c square. Okay, and from that we can calculate this value dc, that is c suffix I have used for the core diameter. Either you can write core diameter or you can write the normal diameter also. If you are going to remove this c, it will become normal diameter, and normal diameter is equal to 0.5 or 0.85 of the core diameter, right? So that equation you can use. This is for the tensile stress. If you want to calculate shear stress, same equation we have to use, but here it will become shear stress is equal to force divided by cross sectional area, where we will take this force as a equivalent shear load. Equation will remain same. Any question? याच्यामध्ये कोणाला काय डाऊट आहे, क्वेश्चन आहे काय? Hello?
No, sir.
No. If not, we will go further and we'll see one example. Now this example is related to the eccentric loading. We are going to see the statement first and later on we will solve it. So statement, I will read the statement for you. For supporting the traveling crane in workshop, the brackets are fixed on steel column. Okay, these are the supports for the train or crane. Okay, and are supported on the vertical columns. Okay, as shown in figure. Okay, I'm sorry. The maximum load that comes on a bracket is 12 kilonewton, acting vertically at a distance of 400 millimeter. Okay, that is nothing but the eccentric load is acting, and that is from the face of the column face we have taken as a reference. The vertical face of the bracket is secured or connected to a column by four bolts. Now here also four bolts are used in two rows. Two rows, that is nothing but the same situation which we have seen previously. We can draw that same diagram, two in each row, at a distance of 50 millimeter from the lower edge of the bracket. The lower edge of the bracket, which we are going to consider as a tilting edge, and that's why they are away 50 millimeter from the tilting edge. Okay. Determine the size of the bolts if permissible value of the tensile stress for the bolt material is 84 megapascal. Also find the cross section of the arm of bracket which is in rectangular cross section, or which is rectangular. So we have to find out the bracket arm dimensions too. That we'll see later on how we can calculate the bracket arm dimensions which is in rectangular cross section. So first of all, we'll calculate the stresses which are induced in the bolt. Now here, if we are going to see the cross section, then same cross section is there. That is nothing but I can copy this same diagram here. I'll crop it. This is how it will look when we are going to observe it from the front side. Okay. So the load which is acting is 12 kilonewton and is acting at 400 millimeter from the reference line, vertical reference line, whereas the bolts are having distance 50 millimeter and 375 millimeter from the tilting edge. If I am going to draw here tilting edge, then this will be the tilting edge, horizontal tilting edge, about which we have to take the moment, and this moment has to be equate with the vertical line, face line. Okay. So as we have seen just now how to calculate the equivalent tensile and equivalent shear load that we have to take for the calculation. First of all, we'll see what is given. It is W as a 12 kilonewton, that is 12 into 10 raised to 3 Newton. L is given as a 400 millimeter. L1, that is the distance of bolt number 1 and 2, that is 50 millimeter. L2 is the distance of bolt number 3 and 4 as a 375 millimeter. Permissible sigma T is 84 megapascal, that is nothing but 84 Newton per millimeter square. Number of bolts which are used are 4. So first of all, we'll calculate the direct shear which is coming because of this 12 kilonewton. So direct shear is nothing but the total force divided by number of bolts. Total force is 12 kilonewton divided by 4. Hence, the load sustained by each bolt is 3 kilonewton. Now the load sustained by each bolt, that is direct shear load that we have calculated. Next, we have to calculate the tensile load which is coming because of the eccentricity. For that, we are going to use the formulae as capital W into L into L2 divided by twice of L1 square plus twice of, sorry, twice is we have taken common, L2 square. Now here we are knowing W, total load which is coming, distance of that load, that is 400 millimeter, in L2 375 we are knowing, divided by 2, L1 distance 50 millimeter we are knowing, 50 square plus 375 square. So WT, that is the tensile load which is coming, that will be 6.29 kilonewton. Okay. Now we have calculated this tensile as well as the direct shear load. What we have to do is that we have to calculate equivalent tensile load and equivalent shear load also. If we are knowing the equivalent tensile load, which is given by equation half into tensile load plus under root tensile load square plus 4 shear load square. So we are going to put various values which we are knowing, and equivalent tensile load value that we are going to get as a 700 sorry 7490 newton, that is 7.49 kilonewton. Okay, now this we are going to take for calculating the dimensions of the bolt. We know that here we are going to calculate the core diameter. Okay, so force divided by stress is equal to the sorry force divided by cross sectional area is equal to stress. So we are going to take cross sectional area to the other side. So force is equal to cross sectional area multiplied by stress. So in this case, we are going to calculate this DC, that is the core diameter. Now, if we are going to take this core diameter, then we are going to get the value of this core diameter as 113.5 millimeter. Oh, sorry, it is square, that is DC square. If you are going to take root of this, it will become 10.65 millimeter. Now, this is the diameter of the bolt which we have to use. But this is not a standard dimension. So, standard dimension which is available is M14, that is 14 millimeter diameter is available. Okay. So, we are going to select this M14 bolt when we are going to consider the direct, maximum tensile stress. Any question? Hello?
No, sir.
Okay. So when we are going to calculate the cross section of R of that bracket, then we'll take the section modulus of that bracket. The section modulus is nothing but Z is equal to 1 over 6 into T, that is thickness, into width square. B is the width. And from this, we can calculate the value of T and B. So what we are going to do is that we are going to take the maximum bending moment on that bracket, and that will be 12 into 10 raised to 3 into 400. That will be the maximum bending moment. Now we know that M by Z is equal to sigma T by Y. So that value we are going to put here, and hence the allowable sigma, that is 84 megapascal or 84 Newton per millimeter square, is equal to M by Z. So here we are going to write Z. Already we have calculated section modulus, that is nothing but M by I into Y. That already we have calculated. Okay. So from this we can calculate the thickness and width. So thickness into width square, that value we are going to get as a 343 into 10 raised to 3. Okay. So here we are going to make one assumption that the thickness is double of that width, or width is double of that thickness, that will consider. So in terms of T, we have calculated B. Either you can select T or you can select B, and from that you can calculate remaining value. Now here we are going to assume that B is equal to 250 millimeter. So we can calculate thickness as a 5.5 millimeter. If you do any question, You are free to ask or we'll go further. Any question? Sorry, okay, today we'll stop here. You can put your roll numbers in comment box and I will take presenting from that and you can leave class.